I want to introduce everyone to Srini again. We got to talk to him earlier today about the story of Aerospike, the company he founded, co-founded, and
A little bit, so.
yeah. And we got to see a little bit of that story and how he started it, how it grew and how it's grown over the years. And I thought it would be really great to come and get together and have like a little fireside chat. You guys can feel free to ask questions. I will be watching chat. And as well as just ask him some questions about what he's excited about in the database space. Like that's what they do here at Aerospike. What we do here at Aerospike is databases. And I wanted to pick his brain a little bit about the future of databases. Obviously, we have these new things, graphs and vectors and those types of things that are being explored more heavily now. But, yeah. I'm just going to leave it there. I know it's a very open-ended, and we'll see where the conversation goes. My mic sounds a bit weird now, Merrick. So let me start from there. I'd like to just have a little chat with Srini about what he sees in the future of databases, what excites him about it, what he's looking forward to in the future, and so let's start there.
It's actually a very interesting question because I actually never expected to be back in the database field, in my career, because I'd been out of the field for almost like 15, 16 years. And it's been now 15 years almost 15 years since, I co-founded Aerospike. So what I am learning in this one, there was a golden age of databases, which is probably about 35, 40 years ago. There were almost like maybe 15 to 20 database systems which existed. It's not the three of them which survived. Eventually it was Oracle, Microsoft, and then, what was the third one? IBM, But then with the cloud, another golden age of databases started, right? I mean, you have DynamoDB, you have Cosmos DB, you have Google's Big Table, various, cloud providers have databases now, and everything is happening on the cloud. So the exciting thing about databases now is I think we are in the second golden age of databases, really. And that's fundamentally what's going on. And I don't think it is going to end anytime soon, okay? Thinking about the future, right? It's, I think, useful to consider how is it that we got here?
You continue, sorry.
So we got here essentially because the internet and the mobile area started essentially generating a lot of data, which was relevant because a lot more people were using services and data-driven optimizations became important. It became important to capture recent activities.
Okay. One second.
I'm going to pause.
The Mac does a emoji and it actually breaks the stream. Sorry about that. It catches reactions and for some reason that doesn't play well with anything. All right. I'm so sorry. The emoji broke the video stream. Hide your hands.
That's pretty cool.
See, it does this thumbs up thing if it thinks you did a thumbs up. And
I see. Okay. Yeah.
That freezes the... I don't know why it freezes the camera.
It's a lot of data.
That's a lot of data.
Yeah. More than voice, for sure.
That's like... it is... So we were talking about the second golden age.
Right. I mean, this is my view of it. Because I'm seeing so much activity, right? I mean, it's not even restricted to just the databases anymore. It's also about streaming systems. It's about, all kinds of real-time activities that happen. It could be like querying these databases, it could be like moving data back and forth. Essentially what's happened is all of this data being generated, mostly the ones which interest me is because it refers to individuals, devices, basically I would say activities like games, things that are going on, right? All of this is essentially can be, I would say, understood, can be used to provide better user experiences in a general sense, but also in terms of generally understanding what's going on. Okay, I'll give you an example. Just there's a customer of ours called Data Miner. What they do is they are just processing all of the news feeds and activities that are happening, and then they identify any important event that is in progress. There's a lot of random noise coming through, but then if they can identify a particular, it could be, a man-made event, a human-made event, or it could be a natural disaster in the making. If they can identify these things earlier, there is earthquake-related, I'm sitting in California, but there's a lot of earthquake-related research where they can actually predict a few minutes before an earthquake where it's going to happen, when it's going to happen, right? But they can't predict it much earlier, but the predictions are like just before it happens, they're able to do it sometimes, okay? And which is similar to that. And that is not about natural phenomena. It could be like a lot of news things happening, people posting, people taking pictures, stuff happening, but if it's a particular event that is happening, it could be like something as tragic as a shooting that's going on somewhere. It could be some other event, for example, a big traffic jam in the making. You could figure all these things out, and the place where it's mostly used is for people in the military, in security services and so on, but it could also be for news organizations which can predict and send people over early and so on. So this kind of data processing capacity didn't used to exist before. It used to exist in a few places in the world. So if anything, the whole democratization of this data, and to some extent, right, one of the things that in the earlier session, we talked about the hybrid memory architecture that Aerospike has. We made a small contribution in making it possible for even small companies to have the capacity to handle workloads like what Google and Facebook or Meta, I guess, is what they're called, and other companies do. So essentially, and Google's called Alphabet, so it's like Alphabet and Meta. So we completely forgotten all the names now.
And
X,
yeah.
Great.
When are we changing?
Except Microsoft and Apple, I think we can still call them those, which is kind of nice. So at least, I'm showing my age, I guess. But the basic thing is the fact that you can have this kind of process. This is why you're seeing a huge number of startups. So if you ask me about databases, what we are doing is we're enabling, and a cloud is a huge part of it, because it's now easy to get a database for you to run things on. The first demo we ever showed of Aerospike was on, I think it was only AWS then. It was on Amazon's cloud, and it worked quite well, even without SSDs and so on. And then SSDs showed up. So there's a whole bunch of hardware innovation that's happening in the storage level, and databases are taking advantage of it, right? This trend is quite, is accelerating, if anything, So I don't think anything is stopping right now. I think it's all accelerating.
Even like, I'm going to say 6 years ago, I don't know the exact amount of time, but like 6 years ago, you couldn't get SSDs in the cloud. And now almost every major cloud has some sort of SSD.
Right.
You have like AWS Nitro and whatnot, and like we're on like Gen 3 of their platform, which has gotten better each year.
Right. And there's more coming, right? Because there was kind of a failed experiment, I would say, with Intel coming up with persistent memory. One of the best technologies ever I've seen, which is great for databases. And we were one of the first companies or first products to essentially work on persistent memory. But that didn't take off. I think, I'm not an expert at it on the business side, but I think fundamentally the cloud providers did not adopt it. So it didn't take off for various reasons.
Why would PMEM or persistent memory, whatever style it, why would that be so big for databases? Like, why do you say that?
Because it got to something which is much faster than SSDs, more closer to memory than SSD in terms of its performance, but it also provided persistence. So if you wanted to have a large-scale system which is real-time, then persistent memory could have been great for that. But it never took off in the sense that the pricing was probably not the right, and SSD started getting better and better with NVMe, and DRAM prices also got slashed. So overall, I think it just didn't survive in the market. But there are people who are working on this standard called CXL, which will hopefully come up with new advantages, right? I mean, new inventions like persistent memory. And then one of the reasons persistent memory failed was because it didn't have the support of the entire storage industry. CXL does, so which enables multiple players to participate in it, and that hopefully will revive some of these new hardware storage technologies, which will also drive database technologies forward. Talking about the future of databases, a part of it is about leveraging the new storage technologies that are available.
Right, because the persistent memory is a thing that can be leveraged. Now we can do cool things with Aerospike to actually leverage that out of the use case.
And here's the other trend, which will be interesting, is cloud providers, have two kinds of models to manage data. One is what I would call the shared nothing model, which is how Aerospike runs today, where you have essentially instances or machines, nodes, VMs, whatever you want to call it, which have certain capacities in terms of CPU, memory, networking, storage, various types of storage. And then you add those things, and then together you form a system. Okay, and that typically means that you're not sharing any of those resources across these nodes. But then the system on top utilizes all of these resources, just kind of how Aerospike works today. However, there is this other trend, so in the trend of having instances, everybody is building better and better instances. Amazon has its, I4Is and I4Gs, G for Graviton, I for Intel, and the first I is for instance. So, and the 4 is the first generation, I'm assuming. But the point is, there's a whole bunch of innovation going on in terms of putting together these instances. And Google just released Z3 in their Google Next conference last month. So they're making advances. These are like instances with SSDs, to your point, as well as other modern architectures.
Better network, better
everything. However, there are also these other thing cloud providers do. All of them do this. Like EBS, for example, is something Amazon has, elastic block storage, for those who don't know what it is. But the point is, it is a service which is available, which has replication built in. It is super solid. And essentially it has, then you just have compute in your instances, and then you can attach data to EBS. Aerospike, for example, supports that, and many other databases support that. Okay, now you're disaggregating compute and storage. And that is, while the aggregated, the shared nothing model with instances is good for certain kinds of workloads, typically mission critical workloads, which need to run very, very high throughput, low latency, high uptime kind of thing, and you can't compromise the latency. There are a vast number of workloads which don't require that kind of behavior. They can run very well on disaggregated compute and storage. So, Aerospike, for example, supports EBS already, but we will continue to work towards that so that's one other trend in databases. How do we take advantage of these kinds of disaggregations of these hardware? So now it's not so much a shared nothing system as essentially it's a network system, right? You have a bunch of compute nodes and then some networking going to certain storage pieces. How do you get the data into the compute to do the work? How do you push down predicates into the storage areas? So there's a whole bunch of things that you can think about in terms of how to build a database, which is maybe not as fast as the other one where everything is concentrated, but it is scales even better, and it's probably more elastic in terms of scaling up with the load in minutes. I'm talking about elasticity in a minute or two, not waiting for hours before the system adjusts, but as the load goes up, the system elastically scales up, and as it comes down on a minute by minute basis, you're able to scale it down. And that can only happen if you don't have to move data around.
Right, if you're disconnected, because then you can just spin servers, the compute down,
Right.
and you could almost spin down to zero,
Right.
because all the storage is held
Right.
separately.
And because if you're in the shared nothing model, where you have instances, if instances go in and out, the problem is you have to move data around. And that's not, we're talking about vast amounts of data. We're not talking about a few gigabytes. So it'll take time. And that works for certain kinds of applications, which are also important. But then there are these disaggregated storage models, which I think become very important, especially if you're talking about vector databases and so on. These could be a great fit for those kinds of databases. And this is actually one of the things which, if you look at some of the cloud database companies like Snowflake and others, they take advantage of this heavily. Because performance is not, even though everybody claims they have the best performance, the point is performance is only necessary to the extent that an application requires it. And pretty much every modern database is faster than the databases of 20, 30 years ago. And even the same databases are faster.
Yeah.
Oracle is faster because they use SSDs. Everybody is faster. So the only issue is, how fast does your application need the database to go?
And that probably depends on the problem you're solving, the data that you have. Is this a security thing, or is this loading my pictures?
But also, is there a need for a quick detection of something that's going on in real time? For example, security is a good example, because the sooner you can detect a breach into your network, the better you can contain the damage of that breach, but also maybe even eliminate the damage if you found it early enough.
Right.
Because one of the things, right, one of the companies we worked with at Aerospike is Cyber Reason. And this was a long time ago when I spoke to their founder. The point that the founder made was very simple. He said, look, it's always going to happen that your security is going to be breached. While it's important to have all the, I would say, the preventive, the various boundary security pieces, you have to have those. He says the assumption they had is like, you have all that, but they're still going to break in. Somebody's going to make a mistake, some whatever, or even maybe there's a hole, there's new vulnerabilities which show up, whatever. Okay, but he says so their whole thing was, hey, moment a breach happened, I'm going to find out. How do they find out? Because a lot of time breach happens and the thing sits there for a while. Okay, so they have a whole bunch of techniques they invented. And you know what? The sooner you can figure out that happened, the better you can protect your systems. So there is a real-time component. Real-time doesn't mean sub-millisecond. Real-time means what is the fastest you can do something to prevent damage, or to compete in the marketplace. If you are in a real-time bidding loop, if you're in a stock market transaction, I mean, these things have to happen right away. And essentially a money transfer, for example, it should happen if I'm transferring, Marek, $5 to you or $10 to you. It should happen within about a couple of seconds, and it should basically be correct. It cannot be that I transfer you $10 and the $10 is both in my account and in your account, or in neither of our accounts, and none of it is actually acceptable. So it has to be exactly in one place. Either the transfer happened, it doesn't happen, and it has to happen within a couple of seconds. It has to happen no matter when I do that, because people's relationships depends on these things, and if the systems don't actually do it right, you're going to have a lot of arguments with people saying, hey, I sent you the money. No, you didn't send it. I didn't get it. So, this kind of stuff, it's amazing like how much people expect this instantaneous behavior, right? And databases are key to all of this stuff. So most of the stuff, like I'll give you an example, right? Today, I'm going to give the example in India because my mom lives in India. And so if she uses her phone, she uses Airtel, or it could be Reliance Jio, there is Aerospike somewhere in there. And then she orders something from Big Basket Groceries. Aerospike is used in that company too. It's also used in Flipkart, which is the equivalent of Amazon. And Aerospike's used somewhere in Flipkart also. And then InMobi, an ad tech company, also uses Aerospike. So if you look at it, right, so as somebody who's just going through their daily life, uses a lot of modern databases. I just use Aerospike as an example. I'm sure they all, people use Redis, people use Cassandra, people use, ScyllaDB, whatever. There are all these databases out there they're all being used in your daily thing. You just don't see them in the applications, but they are all there underneath the covers. And this
The
is
stream has a title that's saved in some database. The video is saved
Absolutely.
in file storage.
absolutely.
Yeah.
And the ads show up if you have ads. It's all basically automatically showing up from various databases, which are real time. And because now this is the difference between the database industry of 30 years ago and now is databases are part of your daily life and the work that and whatever you're doing. It doesn't matter what it is that you're doing. There's a database in there, you're using like 100 times a day in every transaction that you're doing, even those things you don't think are transactions. And that means the future is going to be with the AI, Gen AI, there is a lot of new opportunities that are going to come because a lot of it is about data. Because AI without data is a hallucination, right?
Sometimes it's data.
I mean, I don't know what it is. That's why they talk about like RAG, I think you were showing some applications with RAG today.
We were doing a little, and later today, Art is going to walk us through his whole ragging of the documentation of Aerospike.
Right.
Yeah.
So what I mean is all of it has got data in it. So it's even hard to predict what's going to happen. All I can tell you is whatever's been happening for the last 15 years that I've noticed, it's going to continue. And AI is going to supercharge it even more, in my opinion.
I was going to say AIs need data. Everything needs data. I was actually just thinking about it. You said everything I do on a daily basis. And obviously I work on it as a software engineer at a tech company. I'm like, sure, I used it. But I was thinking about it. I was like, if I take cash to Walmart, well, if I bought something, that would be taken out of a database that's storing how many of the things that they have in inventory and going to some system that says, do we need to order more of these things for this store? And there's security cameras that's storing some sort of footage on me. And they're probably doing some sort of statistical analysis on that footage to know whether I've stolen something or not. Like, even if I myself don't touch an electronic, I've probably interacted with databases.
No, it's absolutely true. And in a way, it's a little weird and scary, if you ask me.
Well, I was going to say, I've never thought about that, where it's like, oh, I went with cash to...
But they warn you. They say that there is public surveillance everywhere, right? I mean, wherever in the world you go, the first thing you see is, hey, there's a camera watching. I don't think cameras are nobody's actually watching, because it's somebody's processing the data in the back end, identifying where people should be watching, right? So there's a whole bunch of data processing happening in the back end. And we get better and better algorithms to match faces and so on. That's where vectors actually help, to get, instead of like going and matching everybody who looks like me or you, it'll just say, hey, it'll just get people who are very close to that. That's what vectors allow you to do.
I'm love today. We've done a ton of learning on vector, and I'm like super excited about vectors because to me, vectors flipped everything I thought of databases on its head. Generally I think of an index where it's like, I have this record, this document, this key, and I want to go get it. I don't want to get something like it. I want to go get that thing. And vectors kind of took it as like, how about we say, you give me this thing, and I'm going to get something like it. I'm going to get you things like it. I think it's pretty cool.
Yeah, it's just an approximate nearest neighbor algorithm. I mean, it's just like the embeddings are good, and it's been around for a while. But the point is, it's actually a foundational piece for much of the work that's happening in Gen AI, as we are finding out, right? I mean, basically, you create the embeddings and you put the data in, you do the search, and now you can feed it to an LLM. Before, there was nobody to explain it to anybody. But now we have LLMs explaining everything to everybody, including our own queries, what we're sending it to them. It's pretty impressive in the sense that we've just got an end-to-end system right now, which actually works much better than typing a SQL query and getting an answer as a table, right? So the whole thing has changed. So you can now do, as we talked about, probably I'm repeating myself, normal life is now integrated quite a bit with a lot of the data-oriented pipelines that we have, including databases.
Now I have to go to a secluded park for a day.
Yeah, but then,
I'm on.
there are satellites.
Yeah, I was going to say.
There are satellites. And there are so many. They're like, what? SpaceX is sending, 5,000, 10,000 satellites a year? I don't know, some number.
I heard that they're like 40% of all the satellites or something at this point.
Yeah, if you're going to looking up and seeing a star, it's probably not a star anymore. It's probably like, oh, okay.
The new constellations.
Yeah. It's moving. Why is it moving?
That's hilarious. Okay, so do you think MRAM? We talked about MRAM. They're stuck on MRAM. Chat is.
Oh, okay.
Yeah. Okay, so cool. So I guess you've broken it kind of into two different things that, or maybe I'm oversimplifying, but there's like the infrastructure side of it. We have hardware that's, I even saw stuff about like a GPU based index, which probably fell flat because there's no GPUs to buy because they're all used for it.
Right now, but it'll change.
Right, but my more point was like, there's just new hardware coming out to power the amount of data. And the reason we're having another database golden age is like, there's just so much data. We found out it's like, you have a cell phone. Do you know how much data is produced by a cell phone, from location data to pictures to, and those things are used to make those things better or to interact better. Like I could send money to people. And then there's like the software side of it, which is more like, we're coming up with new ways to interact with that hardware. We've made that hardware so fast we can do, I don't know, but I would say 20 years ago on a spinning disk, you couldn't have done a vector database because it might not have ever returned fast enough, maybe.
No, you could have done it, but the thing is, the applications didn't exist. See, a lot of the things is not about just technology, right? Technology enables things. And SSDs definitely moved it forward, right? The way I describe that is, if you think of memory and rotational disk in terms of the distance from the CPU, memory is right close to it, okay? It's like in the same room, let's say, just to give a physical example. Rotational disk is halfway across the world. That's the way it is in terms of ratios. SSD is actually probably in the next building, or it's not that far away. And that's a lot of difference, right? It could even be in the next room or 2 rooms down.
Yeah, NVMe, there are 2 rooms.
Yeah, 2 rooms down. And SSDs, when we started, were probably like next building. And now it's like 2 rooms down, right? Persistent memory is just in the next room. That's why it was very interesting. It was not even as far as SSD. It's closer to memory. Now, if you look at it that way, these are like game changers, right? So if you just had SSDs, then you have to put, and interestingly, vectors can all be put in memory. The beautiful thing about a vector database is it compresses the problem space enormously.
Because you're compiling everything into a vector.
So right? Because it's a huge way of compressing the space. And then you can look at neighbor. It will never do an exact search. But once you reduce the problem space to something which is close to each other, you are highly likely to find what you're looking for by just looking at that area. If you know exactly what you're looking for, you can go to a graph database or a key value database or a relational database. You can find it with a key lookup. Okay. Whereas if you don't know what you know what you're looking for, but you don't know, you just don't know where that thing is. Then you just take all the things that are there, compress it into the vector thing, make a query using HNSW and RAG, whatever it is, and then you go in there, and then you get this stuff, and then you go you just look there, and then maybe you'll find it. You got a better chance of finding it if it's there. That is.
Or if it's not there, you'll find some stuff that's like it.
It's like it at least. If that's good enough, and that's good enough for some cases, like cat videos on the internet. Yeah. That's easy to find more cat videos.
We found another use of, we were coming up with uses of vector databases, so finding cat videos. My children are now excited.
Exactly. Cat videos like what you want, right?
Yeah.
Like what you like.
Okay, cool. So I guess, we have the hardware, we have the ways of accessing it. Let's see. I want to open it up some time here now for other people as well. If you guys have questions, I have been checking. So if you guys have some questions that you'd like to ask about the future of databases, where they're going, where they've come from, please do please do ask. With the graph databases, I feel like graph databases are a little undersold just because AI kind of blew up. And I didn't know if you had any thoughts on graphs.
I mean, the thing about graph is it models certain actual relationships. Vector infers these relationships based on characteristics. And it's approximate. A graph is actually direct. Like the fact that you and I are sitting in the same room can be modeled in a graph, right? And when you're sitting at home, across the country, it'll be different, right? I mean, so we can actually model these things based on real data. And I think there are certain kinds of queries, especially if you want to find out, especially, you brought up X, you have all these people who are followers and things like that.
That's concrete. You don't want
concrete, right? So you know exactly who's following whom, as well as how many followers somebody has, and what is the characteristic of followers of a certain person from a certain zip code. You can actually answer these queries fairly clearly. You could go in and do analysis on the entire graph of, if you take the entire graph of, I think you have the whole genealogy graphs. People do analysis on these things, so there's all kinds of graphs, right? I mean, even the DNA thing is a kind of graph. Everything is there are a lot of naturally occurring things, which are graphs, and which means it just gives you a way to model it and analyze it and find answers to questions, right? And the only question is, it's not AI, right? I mean, it's just a foundational thing. Can I combine? The thing that's interesting to me is it possible to combine the real things in a graph as well as a real thing in a relational or key value store with secondary indexes? I mean, these are like not even real things. These are basically specific things.
Specific,
not
things,
approximate.
Real things.
Yeah, and then you can go look at vector. So vector is an enabling technology. It enables you to bring relationships among items which you wouldn't have realized they exist, right? Because you just know there's all this data there. I want to find these, we used the cat video example. You want to find cat videos like this. So you don't know what anything is. You find it. And then you say, I only want to find cat videos of cats which are in my neighborhood or something. And then you can use the graph to figure that out. There are all these combination applications. I gave a very useless example right now, but I'm sure there are various applications that can be written combining vector with graph with other data, and that might become really interesting. This is one of the things I think will start happening is a combination thing, because right now we're going like, we'll build a vector application, we'll build a graph application, we'll build a key value.
You kind of pick one or the other.
Yeah, but I don't think you need to going forward. I don't think we'll need to pick one of those. You could have data which is spread across all of this, and then you would have to solve or answer a question or solve a problem using all of these information. And then you can do it much easier by writing one application which can access all these kinds of data, right? And that's kind of that's one of the approaches I think makes sense, and why, for example, in Aerospike we invest in all of these,
That's actually a really cool concept that I hadn't really thought about, as like trying to combine all of them to like leverage the things they're good at. Vector's really good at finding this fuzzy search and whatnot, and then Graph's really good at making relationships out of maybe the things that you found. And then like you can go get specific data on them with a key value story where you can be like, okay, this video I want to get all of the details of it or whatnot.
Exactly.
That's really cool. Yeah, let's see. Some questions. Are there any hardware announcement developments that you're keeping your eyes on?
Yes, I think I'm always looking at processor and storage advancements, cloud advancements, right? For example, Google's been making announcements, Amazon's been making announcements on how you can get sub-millisecond EBS thing or equivalent things in Google. Cloud, I'm always looking for... When you say hardware, I also refer to cloud as an infrastructure piece now. It's almost like cloud is out there, and we're utilizing it to do all kinds of software on it, right? So the hardware and cloud are... When we started the company 15 years ago, it was mostly hardware, but now it's actually mostly cloud, but hardware still matters because for certain applications, you can run more efficiently. If it's a mature application at very high scale, your own hardware-based deployment will be much cheaper than cloud deployment. I mean, it's just a given. But then cloud is the more used one because it's the more convenient one. You can get started and then you can continue. And if you're making enough profits anyway, you don't care. Right. So what I mean is it's the convenience of it is, and the elasticity of it is really important. So I'm looking for announcements from cloud in terms of the various, like I talked about disaggregated storage things that they have, services that they provide at the lower level, the infrastructure level, which may incorporate NVMEs and other hardware environments. I'm also looking at any storage related hardware like CXL, any activities on CXL. Based storage, as well as new kinds of memory which is coming out, or new processor architectures. Graviton is a big thing. ARM-based processors was big for us. Intel-based, I'm sure there'll be some innovations there. NVIDIA, the whole GPU thing market, that's taking off. So we need to figure out how to leverage it. But that requires a lot of CPU-oriented applications, which are also something we've started to do with graph and vector. We have I would say, a query layer in Aerospike, which is fairly sophisticated for graph, and I would say fairly sophisticated for vector, and it is going to start becoming more sophisticated for graph. So yeah, I mean, those are the kinds of things I would look for, hardware and cloud-based things.
Okay, yeah, that's awesome. I had the perception that we're storing insane amounts of data, but it's still dirty and difficult to handle. I understand the technology solves part of the problem, but when is data just too much data?
This is actually a very good question. The reason is most data is probably not needed, right? Because especially repetitive data, and this is actually the challenge. There are schools of thought here where people have gone. There are people I've met over the years. One of them was CTO of Tapad a long time ago. People may not recognize the name, but he would say like, the trick is to figure out which data is required to make the decisions that you're interested in and focus only on that. And his thesis was about 80% of the data people are storing for solving a problem is not required. It's not 99%. See, that would be a different world. It's more like 80% is still like one-fifth of the data, in his opinion. So the way I would answer that question is, you have to be very skeptical about just storing every piece of data that you can collect. That might be useful for certain kinds of applications which want to go later, comb through everything and find something. But if you're actually wanting to do something with it from a tactical sense, or something which is reasonable with reasonable resources, there is always what I would call as a cost-benefit analysis. And so repetitive data you can throw out. If you find the same, like for example, how much do you need about, like if you're tracking a hurricane, do you need to know what everybody in a zip code is doing on the hurricane? If you had a sample of that, that may be good enough. You use all the normal techniques that we know already, in normal distributions. How much data, like polling does. They don't poll everybody, right? They just have there are these statistical things that you can do with data, which might be enough in a lot of places. Okay.
It's actually a really good one because nobody pulls everybody.
No, you don't need to.
Yeah.
But then the polls are all wrong because basically if people don't tell you the truth. See, the problem with polling is not the data. The problem with polling is the actual quality of what is in the data. People are lying to you. There's nothing you can do about it.
Okay, fair enough.
That's a totally different discussion.
It's not the method for taking the data, it's the fact that...
Yeah, but I'll give you this example, right? In some cases, you want all the data. I'll give you one example. Let's say there is a bridge, or there is let's take like an offshore drilling platform, okay? These things are run in very intense environments, or very, corrosive environments in terms of environmental corrosion, like the salt air, this and that. So you probably want to monitor every bolt, every nut, every nail in there, if you can have a sensor, so you know if something is going to break. If you can identify all of that data, I think you probably need to process and figure out if a particular part of that particular structure is weakening or requires maintenance, and because not having it. And same thing with the factory. right?
I was thinking,
Those are the kinds of things you want to store all the data.
kind of when you were saying that, I was also thinking like your audit log for like access to your production environment.
Exactly.
You just want to store all of that.
All of that.
You're not doing anything with it. That's more of a like you come in because they're,
Yeah.
yeah. Anyways.
Yeah, I mean, there's some data you want to have all of, but if you're just trying to make predictions and so on, I don't think you need all the data. So you got to pick and choose. And that's a good question because one can, I would say, blindly store everything that anybody is sending you. But that may not be...
SSDs haven't gotten that cheap yet.
It's not even cheap. You get lost. I think that's the point of the question was, you just get lost in the data.
Oh.
And then what are you trying to do? And then anything you could have found the problem in 5 minutes. Now it takes you like 2 hours or worse, like 2 days, because you just have a whole bunch of junk you're sifting through.
Or you
find what you need.
Find that relationship because there's too many relationships, and so like that key.
Yeah.
Thing
And so one needs to be, I guess, more intentional in terms of which data to store, which data to look at. And I think that's actually a good principle to follow in this.
Awesome. Any other questions for Srini? Hi, Scott. Scott B., how are you doing? All right, well, if there are no other questions, I want to thank Srini for coming out and talking to us about the future.
Thank you.
Yeah.
It's been a pleasure being here.
Being here in your own office.
No, with you.
Yeah.
That's true. Yeah, you created a whole studio here.
I did kind of create a little den.
Yeah,
I did. I almost got locked out because I went to the bathroom at like 11 p.m. and I almost didn't take my wallet. That was close. But yeah, no, I want to thank you for joining. These are the type of questions where it's like, I know you get, in your position, you get to look at a lot of things like where the industry is going and whatnot. I see a little piece of it, but I don't get to spend, I don't have time. And, it's always really nice to see that side of like, where is the industry going and why is everyone storing so much data? So, yeah. If you weren't in databases, what else would you be working on?
That's a good question. Maybe I'll be like Andy, sailing.
Sailing.
I mean,
not working.
I wouldn't be working on anything else. That much I can answer for sure. Yeah. No, I don't think. Somehow I found a passion at some point. Followed it. I mean, you just try a few things and I would have to try a lot more before I find out what else I was working on to give you a fair answer.
Building.
Yeah. That would be good. Yeah.
I've always wanted to create my own stuff, but it looks like a ton of work, but
no, it's probably going to be fun because it's ancient technology.
Yeah, I was going to say, I feel like the building it with your hands and just like...
Yeah, and the principles are pretty clear. Archimedes figured it out.
Yeah, they can figure it out.
So what I mean is it's like thousands of years old technology. It might be worth doing that instead of doing some newfangled thing which we are doing now. That might actually be interesting.
Yeah. Well, thank you so much for joining.
Thank you, Marek. It's a pleasure.
Absolute pleasure.